Welcome to the mole to mass video. By the end of this video, you should be able to determine the mass of 1 mole of a compound or an element, convert between moles of an element and mass of an element, convert between moles of a compound and mass of a compound, and convert between moles of a gaseous element or compound and its volume. First, let's consider the relationship between moles and mass. Will the masses of 1 mole of everything be the same? We already know that 1 mole is the same quantity of everything. So for example, 1 mole of ants is 6.02 times 10 to the 23rd ants, and 1 mole of hippos is 6.02 times 10 to the 23rd hippos. However, you would not expect the mass of a mole of ants to be the same as the mass of a mole of hippos, because the mass of a single ant is not the same as the mass of a single hippo. Therefore, if we're going to be converting between mass and moles, we need to look at the masses of individual elements and compounds. First, the mass of elements. The mass of elements can be found on the periodic table. We call this the atomic mass, and it's expressed in grams. For instance, looking at the periodic table, we see that the atomic mass of sodium is 22.990 grams. That means that 1 mole of sodium weighs 22.990 grams, or that 6.02 times 10 to the 23rd atoms of sodium weighs 22.990 grams. Likewise, 1 mole of gold, according to the periodic table, weighs 196.97 grams. How about a mole of vanadium? Find your periodic table and determine the mass of 1 mole of vanadium. Here's a few more examples. Notice that in every case, we're talking about 1 mole of the element. Therefore, the number of particles is always the same. 1 mole is always 6.02 times 10 to the 23rd atoms. However, the masses vary greatly because the mass of each individual atom of each element is different. Now let's look at how to convert between moles and mass for elements. This question reads, what is the mass of 2.40 moles of selenium? Again, we're going to use proportions. In this case, the proportion should be between moles of selenium and mass of selenium, because we're given moles of selenium and asked for the mass of selenium. Recall that we can find the mass of a mole of selenium from our periodic table. You're going to need a periodic table for this entire video, so make sure you have one handy. Pause the video now if you don't. The first half of our proportion is the relationship we know. We know from the periodic table that 1 mole of selenium is equal to 78.96 grams of selenium. We're going to set this equal to the information from the problem, 2.4 moles of selenium equals X grams. Again, reading this as a sentence, we would say that if 1 mole of selenium equals 78.96 grams of selenium, then 2.40 moles of selenium must equal X grams. Cross multiply, solve for X, and we find that 2.40 moles of selenium equals 190 grams of selenium. Again, common sense check this and make sure, since 2.4 is larger than 1, our answer should be larger than 78.96, and it is. Let's look at the structure here because the structure is going to repeat over and over again. The first half of our proportion is the relationship we know. In this case, we used the periodic table to determine the mass of 1 mole. The other half of our proportion comes from the problem, and our units line up across the problem, just as we saw in the previous video. Now let's consider the reverse, going from mass to moles. This question reads, how many moles are in 58.70 grams of silver? We're given grams of silver and asked for moles of silver, so our proportion will be between grams and moles. First, using the periodic table, we know that 1 mole of silver is equal to 107.87 grams of silver. Set this equal to the information from the problem, X moles of silver over 58.70 grams of silver. Cross multiply, solve for X, and we find that 58.70 grams of silver is equal to 0.5442 moles of silver. This makes sense based on our common sense check because 58.7 is about half of 107, so we should have about half a mole. Again, the first half of our proportion is the relationship we know from the periodic table, and the second half is the relationship from the problem, and our units line up. Now, what if we're dealing with a compound that contains more than one atom of a given element? In order to determine the mass of a compound, we have to use the periodic table to calculate it. First, we find the number of atoms of each element in the compound, and we add the molar masses of each of those elements together. For example, take a water molecule. A single water molecule contains one oxygen atom and two hydrogen atoms. Therefore, a mole of water molecules contains a mole of oxygen and 2 moles of hydrogen. So, using the periodic table, we find that a mole of oxygen weighs 15.994 grams, and a mole of hydrogen weighs 1.00794 grams. Notice I'm adding that in twice because each water molecule contains 2 hydrogen atoms. In total, the mass of 1 mole of H2O equals 18.0153 grams. We usually refer to this as the molar mass. Here's some practice ones to try on your own. Pause the video here and calculate the molar masses of each of these compounds using your periodic table. When you come back, I'll reveal the answers. Welcome back. Here are the answers. Notice in number 4, I tried to trick you a little. This is not a compound, it's an element, so that one should have been pretty straightforward. Also notice that in number 5, we need to distribute the 2. This is telling us we have 2 of this whole NO3 group. So that means we have 2 nitrogens, 2 times 14, and 6 oxygens, 6 times 16. Now let's look at how to convert between moles and mass for compounds. This question reads, what is the mass of 0.350 moles of HCl? We're given moles of HCl and asked for mass of HCl, so let's set up our proportion. First, we need to determine the mass of 1 mole of HCl, just like we did in the previous slide. Using my periodic table, I see that 1 mole of hydrogen has a mass of 1.01 grams, and 1 mole of chlorine has a mass of 35.45 grams. Add them together to get the molar mass of HCl. Now, we're going to set up our proportion as usual. The first half will be the relationship we know. 1 mole of HCl equals 36.46 grams of HCl. We're going to set that equal to the information from the problem. 0.350 moles of HCl equals X grams of HCl. Cross multiply. Solve for X, and we find that 0.350 moles of HCl is equal to 12.8 grams of HCl, which makes sense since 0.350 is smaller than 1 and 12.8 is smaller than 36.46. Again, this half of our proportion is the relationship we know. We used the periodic table to determine the molar mass of HCl, and this half of the proportion comes from the problem. And again, our units line up. Now let's go the other direction, from mass to moles for a compound. This question reads, how many moles are in 26.20 grams of AgNO3? Again, we need to start by finding the molar mass of AgNO3. Using the periodic table, we add 1 mole of silver and 1 mole of nitrogen and 3 moles of oxygen to give us a molar mass of 169.87 grams. Now we set up our proportion. So the relationship we know is that 1 mole of silver nitrate is equal to 169.87 grams of silver nitrate. Set this equal to the information from the problem, X moles over 26.20 grams. Cross multiply, solve for X, and we find that 26.20 grams of AgNO3 equals 0.1542 moles of AgNO3. Once again, this half of the proportion is the relationship we know, this half is from the problem, and our units line up. Here's a few to try on your own. Pause the video here and solve these problems. There's a mix of all the things we've covered so far. When you come back, I'll reveal the answers. Welcome back. Finally, we need to look at moles when we're dealing with gases. Since gases are generally measured in volume, we should be able to convert between moles and volume as well, just like moles and mass. Since a gas is so spread out, 1 mole of any gas will actually occupy the same amount of space. This is a really crazy idea. We should talk about this in more detail in class. I'm not going to spend too much time in the video talking about this, but this is really, really crazy. What you need to know is that at standard temperature and pressure, which is often referred to as STP, 1 mole of any gas occupies the exact same volume. Standard temperature is 0 Celsius or 273 Kelvin. Standard pressure is 1 atmosphere. At these conditions, the volume of 1 mole of any gas will be equal to 22.4 liters. This actually makes doing the math here really simple because we know that 1 mole is equal to 22.4 liters regardless of what gas we're dealing with. Let's look at an example. This question reads, what is the volume of 4.20 moles of NH3 at STP? We're given moles and asked for volume, so let's set up a proportion. First, the relationship we know. 1 mole of NH3 is 22.4 liters of NH3 because 1 mole of any gas is 22.4 liters at STP. Set this equal to the information from the problem, 4.20 over x, cross multiply, solve for x, and we find that 4.20 moles of NH3 is equal to 94.1 liters of NH3. Once again, this half of the proportion is the relationship we know, this half comes from the problem, and our units line up. Going in the reverse direction, how many moles are in 58.2 liters of argon at STP? We're given liters and asked for moles. So let's set up our proportion. First, 1 mole of argon is equal to 22.4 liters of argon because 1 mole of any gas at STP is equal to 22.4 liters. Set this equal to the information from the problem, x over 58.2, cross multiply, solve for x, and we find that 58.2 liters is equal to 2.60 moles of argon. Again, this half of our proportion is the relationship we know, this is from the problem, and our units line up. That brings us to the end of this video. Let's review our goals. First, we looked at how to determine the mass of 1 mole of an element or compound using the periodic table. Then we learned to convert between moles of an element and mass of an element. Then we learned how to convert between moles of a compound and mass of a compound. And finally, we learned to convert between moles of a gaseous element or compound and its volume.